Hello, my name is Stamatis Misirlis, and today I'm going to show you the cheapest reflow oven ever made. It's a DIY project and I made it myself. Before I show you the device in action, let me give you a quick introduction. For heating, I use two iodine lamps. A good alternative is an O-shaped halogen lamp, typically used in food ovens. To power the lamps, I use power MOSFETs in switching mode, and I use two because they are running on AC. The drive circuit is controlled by an Arduino Nano, and its PWM output works perfectly with MOSFET. For the user interface, I use the serial monitor in the Arduino IDE. When I open the serial monitor, a quick manual appears on screen. The device casing is made from Baklava trays. Baklava is a dessert from the East. These trays are made of aluminum, which is ideal because it withstands high temperatures, distributes heat evenly, dissipates excess heat, and costs nothing. The inner diameter is 20 centimeters, which means you can place a PCB up to 14 by 14 centimeters or about 6 by 6 inches. A good alternative is to use rectangular trays, since most PCBs are rectangular, and so you'll gain space for larger boards at no extra cost. The lower tray houses the Arduino and the power circuit. As I mentioned earlier, it's made of aluminum and also serves as a heatsink for the MOSFETs. The middle tray is where you place the PCB for baking. It is attached to the lower tray using 3 bolts, and it's perforated to allow ventilation on the backside of the PCB. Very important when soldering double-sided boards. You don't want the dark side to get too hot and cause accidental desoldering. On the side, you can see the thermocoupler connected to the Arduino. The top tray holds the iodine lamps. All cables are fireproof and even the terminal block is made of porcelain. Now let me show you the device. So, this is the reflow oven for SMDs. What have inside? This is to put the PCB in some distance from the bottom. The case is from Baklava traces. Here we have two iodine lamps. Those are the heating element. And here we have a type K sensor, this one, which the signal goes down there, where we have a circuit transform the signal to analog, an analog signal that the Arduino can process it. To drive the lamps I showed you before, we have here two MOSFET transistors, two power MOSFET transistors. Here we have a buzzer, and we have two MOSFET transistors because we have AC current. Here in Greece we have 220 volt, and the one is from the half period and the other is for the other half, hemi period, every one of them. This is the main power. This is the cable of the sensor, and nothing else. Here is the USB of the Arduino. I continue. This holes here is to bring some ventilation to under the PCB. In case you made PCB double phase, make the PCB remain cool under the PCB in order to avoid any desoldering of the components because of the high temperature at the upper side. And those holes is for this reason. Those pieces is to align the upper cap of the device so it doesn't fall. This is glass tape that can stand high temperatures, but it's not necessary. You can put something from cotton. Cotton is a fabric that has a relatively
high temperature tolerance. Here the labels say caution, extremely hot surface. I name it Sputnik because it's rounded like the Sputnik satellite. This is we do, but the material is mica, tolerate high temperature. And I put it here because.
And now let's see it in action.
Connect the computer with the reflow oven. I place it here in the Arduino. Now I'm going to show you how this works. We have already connected the USB with the Arduino of the reflow oven, and we start by sending the command S1, switch on. S1 is switch on and S0 is switch off. Here in the serial monitor show stage 1 preheat. And we have also a monitor of the temperature every 10 seconds. You see from the window here and around the device the light of the iodine lamps. That is my opinion. Of course, is better than every other heating element because it's very quick. And this can make the adjustment more accurate. We have already reached 100 degrees Celsius. Now we are in the second stage, shock, which supposed the PCB to goes in a steady temperature and all the parts get the same temperature. Is for the health of the PCB. You are not going to feel that in the video, but it starts to smelling from the high temperature. It's already 150 Celsius. This indications comes from the sensor. The same sensors that adjust the temperature of the iodine lamps. I have placed two iodine lamps, but you can also... right now we have the rise of the temperature. Now is going to solder. Reflow. And now dual, which is cool down the PCB. Now it's supposed the PCB is ready. So I'm going to tell you that this lamp is very cheap, and you can use a lamp like this if you want. It's about $2 in eBay, I think. It's very cheap. Stage 5 cooling. You see the fluctuation of the light. This is because I might need to make the sketch more slower. Always there is some room for improvements in the sketch. Now is 103 Celsius. Now if you want, you can just open a little bit in order to allow temperature to escape. And procedure is completed. And caution, risk of skin burn, because everything here is very hot right now. Okay, this is it.
Cost breakdown. Trays, free. I love Baklava and I have plenty of them. 3 bolts, practically free. Thermocoupler with amplifier, $5. Arduino Nano starts from $2.20. Halogen lamp as low as $1 on AliExpress. MOSFETs around $6. Cables, terminals, and other parts around $5 to $6. Total cost, $20. Not much at all. It's just a fraction of everyday expenses, and it's something you only pay for once. So that's it. A reflow oven that can handle reasonably large PCBs and support double-sided soldering too. I'll be happy to read your comments. Thank you for watching.